Alright guys, I know you've been waiting for this. Last year's budget build video is sitting at like 2 million views right now, and it's time for an update. This is my 2022 5-inch Freestyle FPV budget build. This drone has built-in Bluetooth, can freestyle easily with a full-size GoPro up top, flies pretty damn good without much tuning, and the best part, you can build it for $200. Okay, so I originally filmed this video back in July with this T-Motor Velux light stack, but I ended up having issues with their BMI 270 gyro. I actually went through two of these flight controllers, and both of them ended up having bunk gyros and just didn't work after I flashed 4.3 to it. The drone was constantly twitching no matter what I did. I played with the filters and PIDs, I applied the BMI 270 preset to it, and it just wasn't working. So I had the video all filmed and edited, but I was very hesitant to publish a budget build video with products that I'm not confident in. So I held off and I found an even better replacement stack that I liked a lot better. It has even more features, is cheaper than that one, and is proving to be very reliable. So I literally disassembled the entire drone, and now I'm refilming everything with this new stack on it. If you watched my recent review video a couple days ago, you know that I'm using the SPEEDYBEE F405 stack for this build. It's 50 amps, it has built-in Bluetooth, and is even cheaper than the T-Motor stack I was gonna use. I'm not gonna cover all the specs on this thing now since I just released a video covering everything, but if you're interested, I'll leave a link to that video down in the description. Otherwise, let's take a look at all the other parts that I'll be using for this year's budget build. For the frame, I'm using the RDQ SOURCEONE V3. RDQ does have a new version of this frame, which is the V4. They're very similar, and you'll be able to find tons of 3D printable parts for both. The V4 has been out of stock for some time, so I just went with the V3. Hopefully by the time this video is posted, the V4 is in stock. For the VTX, I'm using this JHEMCU 20x20 VTX. This is capable of 25 to 600 milliwatts of output power, so we should be able to get some decent range out of it. It comes with an antenna, but you can always get an MMCX adapter to use a standard SMA antenna if you'd like. The camera that I'm using is a FOXEER RAZER Mini. This is a 1200 TVL camera, and this is the 4x3 version. I personally prefer 4x3 because you get a bigger image, but you can also get this in 16x9. Motors. A lot of people recommended these motors on last year's budget build video, and I basically recommended these to anyone that had some extra cash to put into the build. These are Emax Eco 2 motors, and these are the 2306 2400 kV motors. These are awesome motors for the price, and since this is going to be a 4S build, I went with a 2400 kV. But if you wanted to run 6S, you can get these motors in 1700 or 1900 kV. For props, I went with these Tri-Blade HQ PB&J props. These are like $3 for a set, and these are just pretty much my go-to 5-inch prop. Now for the receiver. This is going to depend on what controller link you're using. I use Crossfire on a lot of my quads. I also have some that have ELRS. For this build, I'm going to be using an ELRS receiver. This is a 2.4 gigahertz Beta FPV antennaless receiver. This thing is small and it only runs for 10 bucks, so I figured it's perfect for a budget build. And last but not least, of course, the SPEEDYBEE F405 50 amp stack. This thing only costs $69 and is packed with features. Again, if you want to learn more about this stack, I'll leave a link to my review video down in the description. All right, I want to try and keep this guide as simple as possible. Let's build this thing. So first thing you want to do is assemble the bottom plate of your drone frame. Now, the frame comes with all the hardware that you need. I'm not going to show you how to do this because it's pretty simple to do. We'll just fast forward to what the bottom plate looks like all assembled. All right, so I got the frame assembled to this point. I didn't put the standoffs in either of these 4 holes just because we're gonna be working with the flight controller here. This is kind of how it goes together. You have this plate on the very bottom, and then you have the arms sandwiched between this plate and this plate. And when you're looking at the frame, you have these 2 grooves right here with a 20x20 mounting pattern in the middle. And then back here, you have another 20x20 mounting hole, but then you have these kind of slots. These ones actually fit the camera carbon fiber pieces, so this is the front of the drone. So keep that in mind when you're assembling this thing. Up until this point, it doesn't really matter, but once we start mounting the flight controller and everything, that's when it's gonna matter. So just take note of that. Right now, all I'm gonna do is I'm gonna put these longer screws. These are the ones that came with the SPEEDYBEE flight controller. These ones are actually a little bit longer than the ones that came with the frame, so I'm gonna use these. But these are gonna basically just go through the other hole that's part of the arm right through here, and then that's gonna mount the flight controller. All right, so now this is ready for the ESC flight controller stack. Before I do that though, I usually like to mount up the motors just so I can get a better idea of how long the wiring for each motor has to be. When you're mounting the motors, it's not gonna matter which motor goes on which arm. They're all the exact same and you can always reverse the direction in beta flight. One thing to note when you are mounting motors to the frame, make sure that you're using a screw that's not going to go all the way up into the winding of the motor. So this one goes through the carbon fiber just a little bit, so that's going to grab onto the threads good and not go up into the winding. If you notice that if you're using a longer screw that ends up going into the winding of the motor, you're going to burn out your motor and then you can't use it. So make sure that it's not going into the windings. Okay, now that we have the motors all mounted up, let's move on to the ESC. Before we get the motors soldered on to the side pads over here, you're gonna need to get the XT60 and the capacitor on. There's basically two ways you can do this. Personally, I prefer to have the capacitor on the end of my XT60 because it frees up space in the drone. In the footage that you're about to see, I'll show you how to solder the XT60 and the capacitor directly to the battery pads like this. This footage was filmed on this T-Motor ESC. This is the original ESC that I was gonna use for this video, so it'll look a little bit different, but either way, it's gonna be the exact same procedure. So to make soldering all these wires on a little easier, I'm gonna take a little bit of flux. This is just a flux pen, and I'm gonna put it right on the pads that I'm gonna be soldering to. You don't have to do too much. When you're soldering big wires like this, make sure you have a good sized tip on your soldering iron. So all I'm gonna do to prep this is I'm gonna put a little bit of solder on the battery pads. Basically just heat up the pad enough to push the solder onto it. And I'm gonna do this all the way around because I'm gonna have to do it for the motor wires as well. Heat up the pad, put a little bit of solder on it, and don't hold it there too long. Enough to heat up the pad, and then lift. So there we go. Now we have all of these pads ready for the power cable and for the motors. I'm gonna pre-tin the wires, makes it a little easier to solder if there's a little bit of solder already on there. Heat up the wire and then feed the solder into the wire. So on the ESC, you can see a little plus and minus right there. So that means that this one is plus and then this one's minus. So red is usually power. So I'm gonna do red to this pad right here. Kind of press it into the ESC, like that. And then we'll do the same for the ground. Nice. Another thing I'm gonna do for the power is install this little capacitor that was included. So you can see there's a little negative on this side. So that's gonna go right like that. So all I usually do is just kind of bend these a little bit so that they'll fit on the ESC, and then we'll trim it and we'll just solder it right to there. And there we go. Got the power lead all hooked up. All right, so once you have your battery leads soldered onto the ESC, we can move on. And what I like to do is actually take this little ribbon cable that connects the flight controller to the ESC. It's just easiest if you put that in right now, then you can forget about it. This is basically gonna signify the front of the drone, and then you're gonna have the power leads kind of poking out the back. When you're putting this on the frame, just make sure again that you have these little grooves for the camera up front. That's gonna signify the front of the drone, and then this will just slide right over the 30 by 30 mounting holes. Now we can solder up the motors. All right, so your motor pads on your ESC should already have a little bit of solder on them. Basically what you're gonna wanna do, I'm gonna show you this on one motor and then just repeat the procedure for the other motors, but just run the motor wire along the arm, kind of press down as you go, and just make sure that you have enough slack. So I'm gonna have the motor wires run right like that, and then I'm gonna secure this down using electrical tape or something. But basically just make sure you have enough slack, and what you're gonna do is just hold it there, trim accordingly. I already have these trimmed from having this soldered to the T-motor ESC, so they're pretty short. So now these are the correct length for this ESC, and you're basically just going to want to strip these, put a little bit of solder on each end, and then we'll get them soldered to the ESC. So strip these down like this and kind of twist each end so that the wires all stay together. You can use a wire stripper for this. Put a little bit of solder on the end of the motor wires. You might want to use a thicker tip for this. I'm probably going to swap my tip before I try and get these on there. Alright, so once you have solder on there, I know people are going to ask me what this is. This is basically just blue tack. You can get this on Amazon for like $6. I use this a lot to just secure wires so that I can solder to them a little easier. I'll leave a link to this in the description too. So now just kind of run your motor wires how you want them to be ran. I'm going to have this one come off on the side, right like that. And then these other two just come straight on like that. Perfect. And there's a motor. So like I said, I'm going to secure these motor wires down a little bit, but do that all the way around and we'll move on. Look at that. There we go. All right, so now we can mount up our flight controller. So since you already have the ribbon cable on the ESC, it's going to be a little bit easier to plug in. On the bottom of the flight controller, you get 2 ports. This ribbon cable is only going to fit one of them. So plug that in like that, and now that can fit right on top, right like that. So now, since I still have a little bit of wiggle room with the flight controller, I'm going to get the VTX mounted to the back. So I'm going to plug in the wire that came with it, just so that I can see how much slack I have once it's secured down. And what I'm going to use to secure this to the frame is a couple of these screws that came with the motors, and then I'm also going to use some of these little rubber dampeners, and this is basically just going to space the VTX away from the frame, and it's going to provide a little bit more airflow. You don't necessarily have to use these. I would recommend using them if you have them. If you don't have them, you could always use some of these little hex nuts, and these come with the flight controller and a couple other things, so you can always use these to space the VTX away from the frame too. There we go. So I got those 4 screws down, and now I'm just going to place this underneath the power cable, right like this. And I'm actually going to have this cable come out to the right hand side of the power cable, right like that. So now I'm just going to secure that down using some more of these little nylon nuts. Perfect. I'm also going to attach the antenna just because I don't want to forget about it. If you plug a battery in and you have the VTX all wired up and you don't have an antenna plugged in, you can burn out the VTX, so don't do that. Now the VTX is ready to get wired up. Before I do that, I'm going to get the camera ready. To do this, take your 2 plates, your camera, the bracket that came with the camera, and this wire you'll need eventually. It also comes with a bunch of little screws so you can secure this bracket to the camera, and you're going to need to use this bracket. So this just fits right around it, right like this, and then put some screws in there. There we go, and now we're ready to mount this to these pieces. So now when we're mounting the camera, pay attention to how you mount it to this bracket. This little groove is the bottom, and that's what's going to fit into that groove on our frame. And you're going to want these ears kind of facing around there towards the back. So this is going to go on this side of the camera. It's right side up when the plug is on top. So this is going to secure right like that, and you can choose which groove you want. I'm not going to secure that down completely yet. I'm going to get the other side on, and then I'll show you guys how to adjust the camera angle. And just put a screw in the same hole that you did for the other side. So now with those two brackets on, I'm going to put another screw up in that top hole right there. And this is basically the hole, or the screw that's going to adjust the camera tilt. So you keep this one a little bit loose, and then whenever you loosen this one, you can adjust your camera angle. And now I'll just do the same for this side. And now you can take your plug, and this is going to plug right into this right here. And now we're ready to mount this to the drone. This thing's coming along pretty nice. Now the only other thing that we gotta get ready to solder up is our receiver. So this is gonna vary depending on what receiver you're using. Like I mentioned in the beginning, I'm using this ELRS receiver, and this runs on the Crossfire protocol. So when I wire this up, I'm going to be using an RX and TX pad. If you're using an FR Sky receiver, you're going to use the S-Bus pad. So it's going to vary depending on what receiver you're using. But what I'm about to show you is how to hook up an ELRS receiver to this flight controller. So I'm going to start by putting some solder on these pads. So I'm going to start with a black wire, get that on the ground. Like that. Then we got a voltage. Like that. And then we'll do yellow for TX. And white for RX. There you go. Before I attach this to the flight controller, I'm actually gonna coil it up and put a little bit of heat shrink around it just to protect it. There we go. Now it's ready to hook up to the flight controller. First things first, let's put some flux on all of these pads. Now I've already soldered to this, so I don't necessarily have to do this, but I'm just kind of doing it to show you what you should do. Pretend that there's no solder on any of these pads. So you're not going to have to reference a pinout online. You can just kind of look at it and see what you need. So right off the bat, take a look at it. Right up top here, we have 5-volt ground and cam. So those 3 pins right here are going to be used for the camera. Over here on this side, we have a couple 3v3, 4v5, R2, T2, S-Bus. So these pads right here are intended for the receiver. So the receiver is going to get soldered to these pads. So just like the ESC, I'm going to put a little bit of solder on the pads that I'm going to be soldering to. So we got 5 volts right here. Then we have ground right next to it, and then cam. I'm going to rotate it a little bit, and actually what you can do is you can pop the camera out and unplug this, make it a little easier. So ground is going to be the black wire, 5-volt is going to be the red wire, and then the cam is going to be the yellow wire. I'm going to start with the yellow wire. There's that. Now I'll do the black wire. And then we'll do the 5-volt pad. So there's our camera. So now let's do the same thing for the receiver. Now for the receiver, like I said, this is going to vary depending on what receiver you're using. I am using the Crossfire protocol, so pretty much I need a 4v5. I'm going to use that one to power the receiver. Right next to that we have ground. And then if you're using an FR Sky receiver where you need S-Bus pad is right here. I'm using Crossfire like I said, so I'm going to use R2 and T2. Now when you're soldering a Crossfire or an ELRS receiver, basically the way that this works is you have an RX and TX coming out of the receiver, and then an RX and TX coming out of the flight controller. You're going to want RX on the flight controller to connect to TX on the receiver, and then RX on the receiver to connect to TX on the flight controller. And the best way that I can explain this is picture a signal being transmitted from this, and then it needs to be received by the receiver. So it's going to be transmitted out of TX and received on the receiver via RX. So just kind of keep track of which wire is soldered to which pad. So on the receiver I have the white wire going to RX, so that is going to be connected to TX on the flight controller. So just to get that out of the way, I'm just going to do that first. So we'll do white to TX, and then yellow is going to go to RX. Like that. And then we have 4v5, and that's the power. And then we have ground. And there's your receiver. All right, now it's time to hook up our VTX. So I'm using the JHEMCU 600 milliwatt VTX. This one is capable of 7 to 26 volts of input power, but if you're using another VTX like the other one that I have recommended in the description, the Flywoo Goku 450 milliwatt VTX, this is a great alternative to this one. This one will probably get sold out. I feel like for 15 bucks, 600 milliwatts, this one's gonna sell out quick. So for the people that choose to use the alternative VTX that I have down there, that one requires 5 volts of input power, so don't use the 9-volt pad or a battery pad. Make sure you use this 5 volts. Basically just be aware of the input power that your VTX requires. This one is 7 to 26, so I'm going to use this 9-volt pad. Right next to that we have ground, and then right next to that we have VTX. So VTX is going to be the camera image, and that's going to be the yellow wire. And then right next to that we have TX1, and that's going to be the blue wire on our VTX, and that's going to be for smart audio. So now all I'm going to do is put a little bit of solder on the pads that I'm going to use. So I'm using the 9-volt pad. I'm going to use ground, VTX, and TX1. Going to start with the red, or the power cable, and that's going to connect right to this 9-volt pad right here. Right next to that we have ground. Right next to that we have the VTX, and then we have smart audio on TX1. There you go. This is literally pretty much done. All right, so this is pretty much all set. Now it just kind of comes down to mounting everything up and getting the other, actually let's get the other standoffs on here, and just making sure that everything's kind of secured down. The way that I plan on running the receiver, I'll probably end up mounting it to one of the arms, or maybe put it on the battery strap, but I'm gonna try and get it to be outside the drone, because then I'll be getting better reception. If you're working with one of these receivers, the antenna is right here, so when you mount it to an arm, if that's what you're gonna do like I am, probably just want it right like that. I'm sure there's better ways to mount the thing, but I just kind of want to get it out of the drone and away from all the other electronics. So I'm probably just going to mount it right there, or maybe to the battery strap or something. But yeah, so take everything else and just make sure everything's secured down. Make sure you get these standoffs in here, and you'll be good. That's good. You got the camera wire right here. Attach that to the camera. And this just fits right in this groove. All right, so the last thing you're gonna wanna do is plug a battery in and make sure that you get power. So when you're doing this, you're gonna wanna use something like this smoke stopper. And basically all this does is it detects any bridged pads on your flight controller. So if you have a ground and a 5-volt bridged somewhere, this will detect it and it'll stop power going from your battery into the flight controller. So it'll pretty much save your flight controller if you do have a bridged pad. If you're not going to use one of these and you do have a bridged pad, you could ruin your flight controller. So I would highly suggest using one of these. Another thing to note when you're doing this is make sure that you have your antenna plugged into your VTX and an antenna plugged into your receiver if it needs one. So, moment of truth, we got a green light on here, and if it starts up fine, then it's good. If this light turns off, then I have a short somewhere. Looks good. Everything has lights, everything seems to be working. We got the VTX has power back here. This is flashing, looking for my controller, and everything looks good to go. So now it's time for some Betaflight tuning. I'm not going to include a Betaflight setup in this video because I have a completely separate video showing you how to set up a newly built drone in Betaflight. The main things to keep in mind are what UARTs you used for what parts. For this build, the VTX is on TX1, so I'll configure Smart Audio to be on UART1 in the Ports tab, and then the receiver is on UART2, so I'll make sure to turn on Serial RX for UART2. The benefit to using this flight controller is that you don't even need to plug the thing into the computer to do the setup. Since it has Bluetooth built in, you can do it entirely on your phone using the SPEEDYBEE app. All you need to do is plug a battery into the drone. I'll show you real quick how easy it is. And then on your phone, drop down and select the flight controller you're using. It'll immediately detect it, hit connect. So you technically don't even have to plug this into a computer. You can get it set up entirely from your phone. All right, now that this thing is all set up in Betaflight, pretty much ready to fly, I'm gonna throw the top plate on here, get some props on, I'm gonna secure this antenna to the back, and we'll take it out for a flight test. So the flight footage you're about to see, I'm gonna be using this Ovonic 1550 4S LiPo, and I'm also gonna have a GoPro Hero 10 right up front. There you go, guys, my 2022 $200 budget build. It really doesn't fly too bad with a stock tune on it. I did apply the BMI 270 preset, but the stock PIDs on this setup are not bad at all. In the back here, I used a zip tie. Hopefully you can see this. I used a zip tie to just secure this antenna. On my last budget build, the first thing to go out of stock was the VTX. Since the one I used on this build is capable of 600 milliwatts and is only like 15 bucks, I know it's gonna sell out quick, so I wanted to quickly recommend another VTX that I've been trying out that'll work good on this build. and it's the Flywoo Goku 450 milliwatt VTX. And although it's not capable of 600 milliwatts like this one, it does still do 450 milliwatts, which is pretty good. Plus, the outer ears on this break off pretty easily, so you can make this VTX a 25 by 25, a 20 by 20, or even a 16 by 16. Anyways, very happy with this build. All of the parts that I put in this are pretty solid for the price, and I did test them out for a bit before making this video. The SPEEDYBEE stack that's in here is a no-brainer. I feel like you won't find a comparable stack for less than 69 bucks with the features that this one has on it. Having the wireless Bluetooth on it, it really is a game changer, especially for tuning out in the field. I don't know if you can argue about these Emax Eco 2 motors. These are some of the best budget-friendly quality motors on the market, and they have been for the last year or two. The frame is one of the cheapest but most solid frames, plus there's just tons of available 3D prints for it. Obviously, in addition to the drone, you're going to need a headset and a controller, so I'll leave links to some nice affordable equipment down below that can work with this build. Before I forget, I know people are going to ask me how much this thing weighs, so let's just weigh it. So with a 1550 4S LiPo and a GoPro Hero 10, this thing weighs 761 grams. Without the GoPro, you're looking at 592 grams, and dry weight without a battery, you're looking at 400 grams. If you have a couple extra bucks and want to make it look flashy, you can add LEDs like I did here. These are just SPEEDYBEE LED strips, and you can get these for like $5 for a pack of 4 of them. The flight controller has LED pads on the corners, so they're pretty easy to hook up. One last thing that I want to mention before ending the video, I've gotten tons of requests from people to build them drones, especially after I post build videos like this, and I know I'm definitely going to be getting more after this video goes live. This is really only something I do for friends or people in my area. I have dozens of projects that I'm always working on between this YouTube channel and New England Drone Tours, and I just don't have the time to build and send out custom built drones to everyone who wants one. So that's pretty much why I make these videos, so you can learn to build it yourself. And honestly, when it comes to FPV drones like this, if you're going to have any fun flying and doing freestyle with these drones, you're going to crash, and you're gonna need to know how to work on your drone. So links to everything mentioned and used in this video will be down in the description. If you enjoyed this video, make sure you subscribe to the channel, leave the video a like, and if you have any questions about this build, leave a comment down below.
Torn a hawk over here. He's chasing your drone. Go up, go down, go down.